We are now on chapter 11, which is all about gases. So we introduced the idea of gases in chapter 10, right? The very first lesson, we talked about kinetic molecular theory and gases and the properties of gases. What we're going to be focusing on first today is pressure. In the following lessons, we're going to be doing gas laws. Okay. You do need a calculator. Get your calculators out. We're going to be doing math with this chapter. Sorry, not sorry. So we're going to start with just filling in some definitions and some descriptions from your notes. So we're going to start with the PowerPoint, and then I'll switch over because we will do some practice problems today. All right, so we're discussing today gases and the pressure that they can exert. So here's your definition of pressure. Pressure is the force per unit area on a surface. Okay, it is caused by the collisions of molecules. Okay, so as molecules hit the sides, hit the walls of their container, that produces pressure. The units for pressure, the SI units are newtons. Okay, sorry, the SI units of force are newtons. So we usually express it as newtons per meter. But we have several other units that we can use as well that are actually more commonly used. And we'll talk about those here in just a minute. Okay, so here we're describing the units of force because pressure is the force per unit area. So your book starts off by describing the units in terms of newtons per centimeter. So the smaller the area of contact, the greater the force is going to be. So here we have a ballerina in 3 different positions. And so as the area of contact here decreases, her force is going to be the same. Her force is going to be equal to her weight, which is 500 newtons, not the same thing as 500 pounds. So as the area decreases, her pressure, the force that she's exerting is the same, but the area is less, so her pressure is greater. Okay. We have 2 different tools that we can use to measure pressure. So if you've ever read a weather report or listened to the weather report on the news or anything, they'll talk about the barometric pressure. So this is how we can measure the pressure of the atmosphere, and that tells us a lot about the weather. So a barometer is one tool where you have a dish, usually with mercury in it, and then you have a closed tube. So the tube is it's closed at one end, and it's a vacuum inside, so there's no air inside. Okay. So as the atmospheric pressure pushes down on the surface of the liquid, it causes the mercury to rise up the tube. Okay, so standard pressure, normal pressure on and just a normal nice day outside at sea level, the pressure would be 760 millimeters of mercury. Okay, because the mercury would travel 760 millimeters up the tube. Okay. Days where you have higher pressure, the mercury in the tube would be up higher. Lower pressure, it would be down lower. Hey. Okay. So the atmospheric pressure can affect how it affects the height of the mercury in the column. Okay. Another tool we can use is called a manometer. So a manometer is an enclosed gas sample. So the manometer itself is this kind of curvy tube, again with usually mercury inside. And so you would attach your flask that has whatever pressure, whatever substance in it, okay? And if that pressure is greater than atmospheric pressure, then it's going to push on the mercury and cause the mercury in the long side of the tube to rise up. If the pressure inside your flask is less than atmospheric pressure, then it's going to almost pull the mercury towards the flask. Okay. So again, at standard pressure, here where you have nothing, or if you had a substance that was equal to the air pressure, you would have the same level of mercury on both sides of the U shape. So then we can use this to measure how much the mercury moves on either side, and we either add it to our 760. So if the pressure is greater than atmospheric pressure and it's pushing on the tube, we would add it to the 760 and we would find, 800, in this case, 800 millimeters of mercury. If the atmosphere or the pressure is less than atmospheric pressure and it pulls the mercury towards it, then we would find, in this case, it's changing by 40 millimeters. So we would subtract that from our standard air pressure and get 720 millimeters of mercury. So for these two things, you just need to know kind of the basics of how they work. We are not going to actually use them. We have some other tools that we're going to use to measure pressure. So then we are going to move on to units. There are 3 different units that we frequently use, and you need to be able to kind of convert between all of them. So that's actually today's lesson. We're going to define these units. We're going to define standard temperature and pressure, and then talk about how we can convert between these units. And then we have one more thing to do today, talking about what happens if you have a mixture of gases. All right, so the 3 main units of pressure: millimeters of mercury, which is what we've been discussing, atmospheres, and pascals. So we've already talked about millimeters of mercury. If you are at sea level and 0 degrees Celsius, then the atmospheric pressure would be 760 millimeters of mercury. Okay. So if you were to, we've already discussed in the last chapter that if you were not at sea level, as you go up in elevation, the atmospheric pressure is going to decrease. The second unit is atmospheres. So atmospheres we abbreviate as ATM. 1 atmosphere is equal to 760 millimeters of mercury. So it's the standard at sea level and 0 degrees Celsius, it's the normal atmospheric pressure. And then we have pascals, and pascals are related to what we talked about at the beginning of our lesson, where we have a force per unit area, newtons per meter squared, in this case, because those are the SI units for force and area. And so what's actually more useful than the pascal is the kilopascal. So kilopascals, or kPAs, 1 atmosphere is 101.3 kPa. Okay, so these 3 we can convert between any of them because we can relate them to atmospheres at least. So we can even go from kPa to atmospheres to millimeters of mercury. Okay, so you do need to be able to go back and forth. Some of the things that we're going to be asked, or we'll be asking you to do in this chapter, will require that something is given in 1 unit and you have to convert to a different set of units, but they're not really hard conversions. Okay, so we're going to practice those here in just a second. First, we're going to talk about standard temperature and pressure, or STP. This is going to come up a lot as we go through this chapter, so you need to memorize it. It's not hard. It is 0 degrees Celsius, that's standard temperature. Standard pressure is 1 atmosphere. I think you can remember those things. Okay, so STP, 0 degrees Celsius, 1 atmosphere. This is necessary so that we can accurately measure and compare volumes of gas, because as we're going to talk about as we move through this chapter, the volume of a gas changes as you change the temperature or the pressure. Okay, so in order to compare and see what's happening with our gases, we have to measure it at STP. We have to have the standards, right? Like that control group. We have to have that so that we are comparing gases at the same temperature and pressure. Okay. Otherwise, really what we're measuring doesn't matter. Okay. There's no real significance to it, except, well, there's probably some situation where there's significance to it, but when we're comparing the volume of a gas, we need to be measuring it at the same temperature. So the standard for chemistry is 0 Celsius and 1 atmosphere. Okay, so we're going to convert. I am going to switch back here. All right, I have to. All right, so I'm going to switch over to my phone so I can use my camera. Eventually, it's going to let me do that. Oh, spinning the wheel down. Don't do that. All right, now I got to do all the steps. And now we wait, and let's really hope I'm on the right Wi-Fi. Oh, good. There we go. Okay. That's really blurry. Okay, let me turn it. And okay, here we go. Here we go. All right, so we are going to convert first, practice our conversion. So we are going to convert 0.830 atmospheres. So that's the average atmospheric pressure in Denver, Colorado. So Denver, being high up, is going to have less pressure, okay, less atmospheric pressure. So we're going to change that first to millimeters of mercury and then to kPa. All right, so first to millimeters of mercury. All right, so if you look up on your notes, you should have written that, right, so we have our conversion factor is going to be that 1 atmosphere is the 760 millimeters of mercury. Kind of left out some letters there as I was writing. Okay, so we're going to use that as our conversion factor. So we start with what we're given, 0.830 atmospheres. And we are going to convert this to millimeters of mercury. So I start with atmospheres on the top, so I need to get rid of my atmospheres. So atmospheres goes on the bottom. 1 atmosphere is equal to 760 millimeters of mercury. So I'll put that in my calculator, and I'm going to find that that is about 631 millimeters of mercury. Okay. To do the kPa, right, we said that 1 atmosphere is equal to 101.3 kPa. You're going to eventually start memorizing these just because you use them so often. So again, I'm going to do the same thing I just did here, except that I'm going to go to kPas. So 0.830 atmospheres. 1 atmosphere on the bottom to get rid of it is 101.3 kPas. And so if I do that math in my calculator, I'm going to find that it is 84.1 kPa, kilopascals. Okay. All right, so on the next page, you have another set of practice problems. So these are not real hard. You should probably pause the video, attempt to do these. We did not go over torrs Torrs, however, are the same as, now I have forgotten. Torrs are the same as millimeters of mercury. So 1 torr, I'll write that in here for you, is 1 millimeter of mercury. Okay. It's not gonna come up a whole lot. That one is in your book. And there's actually a chart in your book that gives you some of the conversions and some information about them. Okay. So a torr is a millimeter of mercury. So 1 torr, no, sorry, 1 atmosphere is 760 torr. Okay. So now you should pause and work these problems, just these 3, and try to figure out, and then you can come back and we'll see if you got them right. Okay. So I'm going to work them real quickly. So 745.8 millimeters of mercury. There are 700, we're going to atmosphere, 760 millimeters of mercury in 1 atmosphere. So I should get something that is just under 1. And in fact, 0.98 atmospheres. The torrs are going to work much the same way here. So 745.8 millimeters of mercury. 1 millimeter of mercury is 1 torr, so it shouldn't change. 745.8. And finally, the kPa. So for this one, I can't go directly from kPa to millimeters of mercury, or millimeters of mercury to kPa. So I have to go through atmospheres. 760 millimeters of mercury in 1 atmosphere, and then 1 atmosphere is 101.3 kPa. So you'd multiply and then divide by that, or because we did this step up at the top. Oh, man, sorry, it froze. Sorry, my phone closed out on me. That's my bad. I wasn't paying attention. So we did this first step here in part A. So you could just multiply 0.98 by the 101.3. So you get 99.43 kPa. Okay. So I don't think I'm going to switch back to do the Dalton's law of partial pressure. I just don't want to switch back to my phone because it takes so long. So we're just going to write it in. So Dalton's law of partial pressure is our next and our last topic. Okay, so if you're still struggling with the conversions, you might go try some more practice problems, review, but it's a pretty straightforward conversion. So the law of partial pressure applies when you have a mixture of gases. Okay, so the pressure of each gas is called the partial pressure, right? So partial pressure is the pressure exerted by each gas, right? Because each one is going to be exhibiting and exerting its own pressure. Okay, so Dalton's law states that the total pressure of the gas mixture is the sum of all the partial pressures. Okay, so we can write it this way. PT, or the total pressure, is equal to the pressure of the first gas plus the pressure of the second gas plus the pressure of the third gas, plus on and on and on. Okay, however many gases you have. All right, so PT is your total pressure, and then each of the others is the pressure of each gas. Okay, so normally the way that we find this is related to the pressure of water. So there's a couple of ways that you can be asked about partial pressures. So the first one we're going to collect over, collect it based on water displacement. So basically you have a tube with water in it and you collect gas and you measure the volume of the gas by how much water gets pushed out of the tube. When you're doing that, then you have to take into account, so if it talks about collecting by water displacement, you have to find the vapor pressure of the water. Okay. And then, and that's in a chart. Okay, so we'll come back to that here in just a second. All right, so here we are decomposing potassium chlorate and collecting the oxygen gas that gets produced. Okay, so the barometric pressure is going to be my total pressure. Okay, so my total pressure is going to equal the pressure of the atmosphere, which in this case is 731 torrs. Okay, this temperature here is going to be important because I'm going to go look up the total pressure for this case is going to equal the pressure of the oxygen gas plus the pressure of the water vapor. Okay, so anytime you have this water displacement, it means you're going to need the pressure of your water vapor. Okay, and you would look that up in your book. Okay, so the pH2O is in the appendices in your book. We're going to go find table, what is it? It's B8. Okay, so let me go find B8. It's in the kind of second, if you have your book handy, it's in the second set of green, dark green at the back. It is on page R77. Okay, nope, that's B6, sorry. B8 is on page R79. Okay, so it looks like this. I'm just going to move my thing over here. Okay, so you have your temperatures, and then it gives you the pressure in millimeters mercury and in kPAs. Okay, so we are going to find 20 degrees Celsius because that's what it told us. And it gave us the pressure in torrs, but remember torrs are the same as millimeters of mercury. So that's the one we want. Okay, so the pressure of water at 20 degrees Celsius is 17.5. Okay, so I'm going to come back over here. So I know my total pressure is 731. That's going to be equal to the pressure of my oxygen plus the pressure of my water, which we just found was 17.5. Okay, and I really should have marked my page. And so you're going to solve for the pressure of oxygen. So 731 minus 17.5. So the pressure of oxygen is equal to 713.5 torrs. Okay, so water displacement you need to know the temperature and go look it up in the table. So again, this probably pops up on your homework. You might want to go and take a picture of that. On your tests and things, you would be provided with that information, or at least a table that is similar. Okay. A table providing you the information that you need. So that's one way that we can find partial pressure. Okay, so when they do water displacement, you need to know the partial pressure of the water vapor, and then you could have multiple other gases that you're finding the pressure of. You can only find one at a time. For this one is a little different because it's not collected by water displacement. That's not how you might think of it. Okay, so this is the problem on the next page. So instead of calculating or measuring it by water displacement, we just have 4 gases. But this one is different because it gives us their abundance by volume. And so it wants us to calculate the partial pressure based on their volume or their percent abundance. And I forgot to review how to do that. I believe that I should pause this video and go look up what's happening. So let me go do that. All right. It's actually really easy. So let me come back to share my screen. And it's going to take forever. So sorry. Okay. So it's actually really easy. All we're going to do is multiply these percentages that we have by the total amount. But we'll use the percentages as a decimal. Okay, so kind of what it's saying here is if the total pressure, right, is 760 millimeters of mercury, then the volume is really going to, the percent by volume is going to determine how much pressure they're exerting. So if, for instance, nitrogen is exerting 78% of the pressure, then what is that value, right? So we're going to find 78.08% of 760. Okay, so for the nitrogen, we would multiply the 760 by 78.08 as a decimal, that percentage as a decimal. Okay, so if you plug that in, you'd find 593.4 when we're given millimeters of mercury. So we should stick with that. Okay, so take a moment, pause the video, try the other 3 of these. Okay, and then come back and check yourself. So oxygen would be 760 multiplied by 0.2095. 159.2. I don't know why, but it's really hard for me to write millimeters of mercury. The next one is argon, which is 760 times 0.00934. It's a very tiny percentage, which gives you 7.10 millimeters of mercury. And finally, CO2. 0.035, 0.27. So if you add up all four of those numbers, you should find that they add up to 760. Okay, so that's another way that it could be asked. Most of the time, it's not going to be asked that way. So you should go ahead and pause the video again if you've checked your answers here, and try this one. This one is collecting it says it's collecting over water, so that's water displacement. So you're going to need that table in the back of your book or the picture that you took of it if you were smart. So pause the video, try to calculate this one, and come back and check your answer. Okay. So my total atmosphere, so the barometer in this room is not reading 760, it's 743.3 millimeters of mercury. Okay. So I need to go and look. I did not take a picture. So let's see, the temperature is 27. So water vapor pressure is 26.7. So my pressure total would equal the pressure of neon plus the pressure of water vapor. So 743.3 minus the 26.7 would give me neon, which is equal to 716.6 millimeters of mercury. Okay. All right, so that's the end of the lesson portion. You still have this practice page. So you need to work on that. So we have just kind of so the first one is kind of a hypothetical situation, just asking you to apply the concept. Do what you can with that one. And then we're converting here. You're converting atmospheres to torrs, which is the same process as converting to millimeters of mercury. Number 3 is again asking you to do some more conversions. And then 4 and 5 are partial pressures. So for 4 does not use the water displacement, so you don't need the chart. Okay, so you just have 3 gases. Okay, so we have a mixture of these 3 gases, and at 1 atmosphere, it gives you 2 of the partial pressures, and it wants you to find the 3rd. Okay, so that's one step here. You don't have to go look up the water temperature. But for number 5, you are collecting over water, so you will need that chart. Okay, I've left answer key, so check yourselves when you get done or as you're going. Make sure that you understand how to do this so that you can do a good job on your homework tonight. Okay. Once again, message me with questions. Let me know what you've got. Let me double check on your, so you've got a lot of multiple choice, and then you've got some conversions. Oh, on the back side, it doesn't ask you to explain that that process that we went through for finding the partial pressure of a gas that's been collected over water. Okay, so you have to tell me how you would do that. Use your own words, but tell me how you would do that. But be specific, like give directions that someone else could follow, not necessarily someone else specifically in your class, but just anyone else. Okay, and then you have just some partial pressure conversions and calculations. Okay, so you want your calculator. Again, if you haven't done so yet, and you want to take a picture of that chart in your book so you have it handy, snap that real fast and then put your phones back away, please. Okay, message me with questions. Try to get back to you. I make 0 promises.